I've written the rule for multiplying any two positive or negative numbers over here on the board. The rule says to multiply two real numbers, multiply absolute values. So that is, you just forget the signs and multiply the number parts. That product, or the answer, is positive if both numbers have the same sign and negative if the two numbers have different signs. So I'll just simply multiply absolute values. If the two numbers I'm multiplying have the same sign, the answer is positive, and if the two numbers I'm multiplying have different signs, the answer is negative. In all cases, you see the absolute value of the answer is simply the product of the two absolute values. That is, we just forget the signs and multiply. 3 times 5 is 15. You already know that. Negative 3 times negative 5 is also 15. 3 times negative 5 is negative 15, as is negative 3 times positive 5. So multiplication is a pretty easy operation. You simply multiply the numbers. The answer is positive if the two numbers have the same sign, and it's negative if the two numbers have different signs. Let's look at some examples. First, I want to multiply 2 times 3. Now, I'm going to just show you how we justify this rule real quickly. 2 times 3 means 3 plus 3. That's the definition of multiplication. It means write down 3 2 times and add. 3 plus 3 is 6. Now, 2 times negative 3, by the same definition, is negative 3 plus negative 3. That is, I want to write down negative 3 2 times and add. Negative 3 plus negative 3, negative 6. Negative 2 times 3, I'll solve that problem by using the commutative property of multiplication to rewrite this as 3 times negative 2. Now that's negative 2 plus negative 2 plus negative 2. And when I add those three negative 2's up, I also get negative 6. So you see, I can justify this rule I have for multiplying positive and negative numbers simply by going back to the definition for what multiplication is. That multiplication is repeated addition. So 3 plus 3 is 6. Negative 3 plus negative 3 is negative 6. Negative 2 plus negative 2 plus negative 2 is also negative 6. So you see, in each case, we simply multiply the two numbers, we get a 6. If both numbers had the same sign, the answer is positive. If the two original numbers had different signs, then the answer is negative. Now, how do we justify negative 2 times negative 3? It's difficult this way because I can't write negative 3 down a negative 2 number of times, or I can't write negative 2 down a negative 3 number of times. But what I can do is this. Let's look at 3 times negative 3, 2 times negative 3, 1 times negative 3, 0 times negative 3, and now negative 1 times negative 3, and negative 2 times negative 3. And let's see if we can see a pattern. 3 times negative 3, if I multiply those, I get negative 9. 2 times negative 3, I multiply those, I get negative 6. 1 times negative 3 is negative 3, and 0 times any number is 0. Now, if I just look at this pattern right here, negative 9, negative 6, negative 3, 0, and ask myself, if I want to continue that pattern, what would the next number be? The answer is 3, and then after that, 6. So according to this pattern right here, the product of negative 3 and negative 1 would have to be positive 3, and the product of negative 2 and negative 3 would have to be positive 6. So in any case, that's what we're going to use for our rule. We'll multiply absolute values. If the two numbers have the same sign, the answer is positive. If the two numbers have different signs, the answer is negative. Now, if I multiply three numbers at a time, 3 times negative 2 times 4, I multiply two of them first. 3 times negative 2 is negative 6. And then that's multiplied times 4. Multiply absolute values, get 24. The two numbers had different signs, so the answer is negative. Likewise for this problem, negative 1 times negative 2, positive 2. And then that's multiplied times negative 3. I multiply absolute values and get 6. Two numbers have different signs, so the answer is negative. So see, applying my rule for multiplication of positive and negative numbers is really pretty simple. The next problem we're going to do involves an exponent. Negative 2 to the third power. I know by definition that this means negative 2 times negative 2 times negative 2. Now I'll multiply negative 2 times negative 2, that's positive 4, times negative 2 again, that will be negative 8. So negative 2 to the third power turns out to be negative 8, and I use my definition for this exponent as being repeated multiplications here to give me negative 8. Here's our next example. Simplify. Let's work inside the parentheses. Negative 3 plus 2 is negative 1. 4 times negative 1, negative 4. Down to our next example. I'm going to work inside the brackets right here. This is negative 7 plus 2 times negative 5 plus negative 9. Now remember, this is a subtraction problem, but I think in terms of addition. So negative 5 plus negative 9 is going to be negative 14. Now I continue here. I have addition and multiplication. I want to multiply before I add. Negative 7 plus negative 28. And negative 7 plus negative 28 is negative 35 when I add. So there's a combination of subtraction, multiplication, and addition with positive and negative numbers. Another more complicated problem here. Negative 3 times 4 minus 7 minus 2 times negative 3 minus 2. Inside the parentheses is where I'll go first. 4 subtract 7. I think to myself 4 plus negative 7, that's negative 3. Minus 2 times negative 3 plus negative 2, which is negative 5. Now I'll multiply negative 3 times negative 3, that will be positive 9, minus 2 times negative 5, negative 10. And 9 minus negative 10 is the same as 9 plus 10, which will give me 19. So I apply my rule for addition, subtraction, and multiplication with positive and negative numbers, along with my rule for order of operations to work some more complicated problems. Here's our next one. Let's subtract negative 3 from the product of 5 and negative 4. So I'm going to subtract this negative 3 from the product of negative 5 and 4. So here's the product of negative 5 and 4, and from that I want to subtract a negative 3. So notice that I have to put my own subtraction sign in for this word subtract. So subtract negative 3 from the product of negative 5 and 4. Now that will be negative 20 plus 3, because subtracting negative 3 is the same as adding positive 3, and that will be, of course, negative 17. So a nice translation of a problem written in words into an equivalent problem written in symbols. You see I have subtraction, multiplication, and then also addition in the same problem.